Hi everyone. In this video we're going to go through some help if you need it for the, let's see, this is activity number 8. Alright, so you should obviously read through things, see if you can figure out what everything means. One thing that might be helpful is on this guy over here on the right, it might be helpful to label each interior region using the 68, 95, 99.7 rule. And by that I mean if I take that 65, cut it in half, that puts 34% there, 34% there. If I take 95 minus 68, that is equal to 27. Cut that in half, and you get 13.5% in each of these smaller sections. And then 99.7 minus 95 is 4.7. Cut that in half for each of these two regions, and you get 2.15%. Actually, correcting myself there, that's 2.35%. That should be a 3.5. There we go. And then here's the 0.15. On the outside of that is 0.15% for anything outside of 3 standard deviations. Okay, highlighting the important things here. For our 7-ounce bag of M&Ms, the mean number of M&Ms is 210, and the standard deviation is 2. So our mean mu is 210. Standard deviation sigma is equal to 2 M&Ms. Scrolling down here, they asked me to redraw the normal curve. We've already got it redrawn for us. And if you're in Microsoft Word, you can type right on top of the picture, or you can, if you have it printed, you could certainly just handwrite this as I am. All right. So redraw the normal curve with appropriate numbers along the bottom axis. What I mean by that is starting in the middle, we have our mean 210 M&Ms, and then I'm going to add and subtract the standard deviation as you build out from 210 M&Ms. Now, when you look at number 2, what percentage of bags do we expect to contain between 210 and 212 M&Ms? Well, if you did the labeling that I suggested at the top, 210 to 212 is this region that I am going to shade here. There we go. That looks better, kind of. That's that region. If you labeled at the top like I suggested, or rewind the video a little bit, you will be able to see exactly what that percentage is there. It's half of that 68%. That's my answer to number 2, straight up. And then out of 50 bags, if we only had 50 bags, what percent of them contain this amount? And so we want to know whatever percent we answered for number 2, what is that percent of 50 bags, or times 50. That percent that you answered times 50 is your answer to part B. For 3, 4, 5, and 6, you just have to look carefully at your normal distribution, making sure that you answer that you're looking at the correct part of the bell curve. So at least 212 M&Ms means 212 or more, right? That's what we're looking at on the bell curve, and then you're adding up those percentages. Between 208 and 210 M&Ms, again, that's just you're looking at that one select region of the bell curve. If you have it labeled already on your paper, that answer shouldn't be terrible. Number 5, what percent do we expect to contain at least 206 M&Ms? Again, that means 206 M&Ms or more. Add up all of the regions containing 206 or more. Number 6 are, again, what percentage is between two values? Highlight them on your curve, add up the percentages between those two values. What percent do we expect to contain 206 and 214? Again, it's the same idea. And then lastly here, out of 50 bags, now this is a how many, right? So I want to know your X percent of 50 bags, and that is your percent again times 50. Make sure that you convert that percent to decimal form. And what percent am I using? Well, you're using the percent that you answered in number 7, or in part A, excuse me. So you're adding up the percentages to answer part A, and you're multiplying that percent in decimal form, you're multiplying that percent times 50. All right, there you go. That's it. Well, you got to actually do the math now, but hopefully that gets you started with this activity. If you have more questions on it, please don't hesitate to ask. Thank you for listening. Have a wonderful day.